Yeah, my name is Chris Fregly. I started off at Playboy. I keep the Playboy thing up here because it actually comes into play a little bit later. It's been a few years, and yeah, that's me at the mansion with my boss and his wife. Back in my younger, thinner days. That's me and my mom at Netflix. Moved out here from Chicago to join Netflix. Joined Databricks shortly after. And then now I'm at the IBM Spark Tech Center. Well, not short, this is 5 or 6 years later, so, okay. Yeah, also want to mention, I run a Spark meetup group here called the Advanced Spark Meetup Group. If you just Google it, it's pretty easy to find. There's about 1,000 people that we've gotten in about 3 months. So, and then, of course, IBM has been backing it. And if you... Yeah, it's like pretty much a dream job, right? My job, my boss, my company support this fully, which I didn't believe. I asked everyone before I joined. I'm like, is this for real? Can I not wear khaki pants, pleated khaki pants? Can I just wear my shorts and flip-flops? And they said, yeah, that's good. So, yeah, that's why I joined. So we're hiring. We're only hiring nice people, not the Ehrlichs over here. So speaking of the meetup, actually Monday, I planned this right before the Cassandra Summit because I knew a lot of DataStax people would be in town from all over. So DataStax was kind enough to host it right down the street at their office. If you Google, there's 2 slide presentations. So Russell, who I think is actually talking right now, possibly talking about the Spark-Cassandra connector, he has about 90 slides. That actually goes into more depth than he's covering here at the summit, so you might want to check that out. And then I have my slides, which is about half of these slides, so you won't be missing too much. And then the upcoming ones, Project Tungsten, you probably heard about that, Spark. And then focusing on the Elasticsearch connector. There's a lot of people asking about the internals, so going to focus on that. And of course, Catalyst deep dive. So we'll try to blaze through these recommendations, live demo, talk about data frames at sort of a high level, and then dig into what the Catalyst Optimizer does and the various query plans. We've got Data Sources API, that's the main API. So when Russell and Piotr and Alex and those guys went to write the Spark-Cassandra connector, that's what they used, right? That Data Sources API from Spark and Databricks has changed quite a bit over the last year. So, they did a really good job keeping up with that. Wow, that was crazy. All right. We'll talk about how to create, your own custom data source. We'll talk about native ones that are part of Spark. We'll talk about third-party ones that people have built. And then a few tips on Spark SQL performance tuning from my work at Databricks and currently with IBM. So just real quick, you guys probably know this, but there's a couple types of recommendations, right? There's personalized, non-personalized. We saw this quite a bit at Netflix. I'm sure there's a lot of Netflix people in here. The whole cold start problem, right? What do? You don't really know anything about the user, so you just do normal summary statistics, find out which movies are popular, which ones you can kind of seed with. Now that changed when they went and they added Facebook integration, right? Because then instantly now you have a graph that you can pull from. So you can also do things like PageRank. You can just kind of look and see which movies people are liking. This is like a dating data set that we'll be showing. So it's user to item, but the item is actually another user, right? So it's kind of funny. And then personalized, you can do things like collaborative filtering, matrix factorization. We'll have a demo of that in a bit. So this is interesting. This was some terms I picked up, probably the past couple of years about different types of user feedback. And back in the early days of Netflix, they relied on ratings or people liking each other. Picture like Tinder where you're just swiping. Those are just likes. They're not 1 to 5, 1 to 10 ratings. It's just zeros and ones. But you can't really count on that, right? So there's these other types of feedback called the implicit feedback, which is like hovers and searches and clicks and, right, like how long you spend watching the movie, how long you, right, like view the person, if you click in to see multiple pictures of the person, if you spend time reading the, right, like movie, like summary and all that kind of stuff. Yeah, so all that gets fed into these models, obviously, for future recommendations. So yeah, that's the big data, right? Just a quick note on similarity. I mean, this is what it all comes down to, right? We're trying to find user-user similarity, right, like user-item similarity. Item-to-item similarity was made like pretty popular by the guys up at Amazon. So yeah, and I mean, it basically all comes down to math, right? So how far in like vector space are these things? Yeah, trying to put a number on each of these items or these users, and yeah, then calculating angle distance and, right, like Euclidean distance is kind of the most basic. There's this concept of log likelihood that's sort of associated with Jacquard similarity, where you factor out popular. So at like Netflix, for example, right, like everyone, the first week you were there, you have to say what your favorite movie and TV show was, and yeah, right, like I guess like 85% of right, like people said Shawshank Redemption, so that was kind of funny, but yeah, that would be an example of, like, that's not really like a high value recommendation, right? So you want to factor that out. So yeah, those are techniques to do it. Yeah, here for this case, I've got Matei as the most popular person people were picking. Yeah, he's a really really popular guy with the ladies. Yeah, he's founder of Databricks. Okay, yeah, and then comparing similarity. I mean, this is the whole challenge here, right? So you basically have to compare, right, like everything to everything else, and of course that's the scariest thing in the world, right? That's like Cartesian, that's tons of shuffle, that's huge cost, right? Yeah, like network cost. So there's clever ways to do it. You can approximate, right? That's the most obvious. So trying to reduce M, which is the number of rows, you want to bucket. There's this algorithm called locality-sensitive hashing that probably comes up about once a week in my inbox, people asking about this. Yeah, so that's one to keep an eye out on. And then to reduce N, right, like you can use sparse matrices and pull out common values like 0. Yeah, something interesting, 0 like sometimes isn't, right, like the most popular, or yeah, the most frequent item, so, or yeah, the most frequent value, so keep an eye on that. All right, this is, oh, yeah, so this talk used to be called Spark After Dark. It's still kind of out there on the web. So it was, yeah, since like my Playboy days, when I first joined, I was too young to know about Playboy After Dark. I think it was in the 60s or something. And I got a hold of all the footage and started watching, and yeah, super progressive, right? Like Marvin Gaye, yeah, old school Jerry Garcia, and of course Hef in his heyday there with his short haircut. Yeah, so that's kind of where all this came from. So this is what I need you guys to do, and then I'll do it with you. So this is sort of, yeah, there's this project called Flux Capacitor. Yeah, if you guys have seen me talk before, I tend to use Flux Capacitor for various projects I've done throughout the years. It started off with a Netflix project, and now it's yeah, switched over to big data. So we've got Kafka, we got Spark Streaming, Cassandra, we've got MLlib generating the models and then making recommendations, putting recommendations into Elasticsearch, right? Like really for no good reason. I just wanted to like demo the Elasticsearch connector and see how it worked. And then the user, yeah, so the user talks, so the user being, if you go to Spark After Dark and select 3 like actors and 3 actresses, that's now coming into Kafka, which is listening. Yes, I have a Docker image sitting out on a soft layer. Yeah, I was using Amazon up until like 2 weeks ago, and yeah, IBM started kind of pushing me towards soft layer, but it's a bare metal, yeah, like piece of hardware, so it's actually pretty fast. But yeah, so if you guys just want to do that for a little bit, for like a minute. I'm going to do it too. This is totally anonymous. I don't know who you are. and the data is going to get blown away when I get rid of the Docker image anyway. So just pick a few of your favorite people. Yeah, both men and women, doesn't matter. We're all like adults here. We're all in the Bay Area. So this is Apache Zeppelin. I'm going to make sure I zoom in here. I usually don't go about 10 seconds without someone yelling at me to make the screen bigger, so I've gotten better about that. Right, like have you guys used notebooks? Have you used IPython notebook? You guys, yeah, raise your hands. Yeah. So, yeah, very similar to that. It's going to look a lot like this. Right, like Databricks has a product, used to be called Databricks Cloud, now just rebranded Databricks. That's also a notebook type thing. They support R, they support, right, like a lot of, like the advanced commercial features. But yeah, Zeppelin is open source. So here I'm just importing libraries. I've got the Cassandra connector, I've got Kafka, and let's see, some CSV stuff here. So yeah, so like when you're clicking on the actual page, that's calling a REST API into Kafka. That's a, right, like Confluent, the company that spun out of like LinkedIn. Those guys have been building a REST proxy, which is super valuable. I don't know if anyone's actually going to use it in production, but for me it was awesome for this demo. I could just make REST calls out. Yeah, just right, like doing Ajax-y type stuff. And then Spark streaming, so there's a job running. So, right, like Zeppelin itself is a job. It's a long-running job, basically, just like Spark Streaming is a long-running app. This is actually this one here is a Spark Notebook. Spark Notebook is also its own long-running Spark app. That's kind of how these things get away with running within a, like, typically batch-oriented type of system, right? So, yeah, so this is just running out there. It's just basically pulling off Kafka every 5 seconds or every, I don't know, I think I did 1 second, but just pulling all these numbers off. So if I go back to the notebook, I should see, what's going on there? And then, yeah, it's basically pulling it off Kafka and then sticking it into Cassandra. And then from there, we can pull out the data from Cassandra and generate the models. Start that one. Get rid of that one. Okay. So let's just run this from the beginning. See how it goes. So yeah, just to show you guys some of the code. So I'm just setting up reference data right here. I basically just pulled it off IMDb. Actors, actresses, profiles, their bios, pictures, things like that I can just join just to make some of these charts a little bit more interesting, showing names instead of IDs, right? So that is just reference data. So yeah, we got Leo in there. We got, I just went to IMDb and searched I think like top or like best looking actors, best looking actresses, and I just got someone's list or whatever and then converted it. I'll probably get sued, but that's okay. Okay, so that worked. Count. This is going to be how many likes have come in off of Kafka, which I hope is greater than 30. All right, so we got 900. This guy's going to keep, this is just going to display. So this is the from, so the number that is on your guys' webpage is the one on the left, that's from, and then 2 is going to be one of the 15. 9,000 I think is the females and 1,000 is the males. Yeah, by the way, like your recommendations are going to have both. In fact, I had one time where all 5 of my recommendations were guys, so I'm not quite sure what was going on there. I have to tune that a little bit. Okay, so most desirable users. This is most desirable actors, actresses. Of course, Sophia shows up there for Modern Family. So let me do crank up the count here to be. Oh, I think it's still running the rest of the. Yeah, so very quickly here, yes, I want to get into what the actual plans look like. There's a way to show, all of the different plans. So there's, just like SQL, there's a logical plan, there's an analyzed logical plan, there's an optimized logical plan, and then the physical, I'll show you guys. So you can basically take any SQL statement and run explain true, and it'll show you all the different, I think it's still probably chugging to get to the end there. All right. So this is just plan stuff. We'll, it's trying to rerun I just want to see who the top 5 or 6 are. It's always kind of interesting because it's different with every crowd. But yeah, Sophia shows up almost every time. So, Leo. Ashley Judd, that's a new one. Oh yeah, Tiffany Amber Thiessen. Yeah, she's my personal favorite. Okay. So let's generate, so this is the non-personalized. So the only real interesting thing besides just kind of summary statistics here would be the page rank. So let me run this from the top, if I can. Yes, I'll start showing you guys the code too. So, basically I take the results of that first notebook and I'm sticking it into Elasticsearch. There's something going on with Elasticsearch. It got wedged earlier today, but so that would be, and then here's some page rank action here. Pretty typical, but if you think about it, you have all these people on the left that are liking all these people on the right. Picture Twitter kind of swiping along, right? So you've got this big, bipartite graph going on here, and you're contributing your likes to them, and they're contributing back to the rest of the. Yeah, this is like my buddy right here. He just likes everyone just because he thinks that's how he's gonna. You just play the numbers, I guess. All right, so let's try to do, so let's get to the interesting stuff here, which is going to be the matrix factorization. We can get back to this later, but basically what it would do is populate Elasticsearch, and then when you click those 3 links at the bottom, those are personalized to you. It knows your ID, and it would grab it out of that. It would pull it from Elasticsearch. All right, so if you guys want to see some more of this in action, github.com, flux capacitor, and then there's a Docker image that has all of this built in. So it's got Kibana, Logstash, Ganglia, all the metrics and all that kind of stuff. So it's pretty cool. All right, so data frames, inspired by R and pandas. I'm gonna just kind of blaze through here. You should always be writing to data frames. There was a big shift in this as of Spark 1.3. Yeah, there's a lot of performance gains going on there. There's a lot of code generation happening right like beneath the scenes. If you write to RDDs directly, you're bypassing that. So when you write to data frames, that participates in the this whole catalyst optimizer. So so think of a data frame as a logical plan container, like Pig or like SQL, that kind of thing, where you're just building up transformations, building up a DAG, but then Catalyst is the one that actually comes in. So, like Catalyst was a rewrite, like initially there was Shark, and so Shark was basically Hive on Spark, and it used the like Hive optimizer beneath the covers, and it really wasn't. It didn't fit into the Spark like execution model. It was more like MapReduce. It was limited by that. So there was kind of a like sit down, like a big meeting where they decided, let's just rewrite this thing. It's going to be a long road ahead, but they have smart guys. Yeah, these guys have PhDs and this kind of stuff. So they set out to do it. And keeping it clean, keeping it open too. So that's the data sources API that we'll talk about in a second. You can plug things in. You can plug in custom rules. You can, basically hook into any plan that you want. You can like manipulate it at all the levels, logical, physical, optimize, that kind of thing. Yeah, so you can write custom UDFs. The one drawback to this is that Catalyst doesn't understand what's going on beneath that UDF. So you might actually have some problems if you start like doing crazy things in there. So Catalyst has to optimize around it, can't include it in the fun. And then as of Spark 1.5, there's a new UDAF support, for like custom UDAFs. Right now, the only like UDAFs you can use are the Hive UDAFs. So Spark SQL is essentially a close subset to HiveQL. Like close meaning there's a few obscure things that Spark SQL doesn't implement. Like one of the things IBM and Databricks have been talking about together is trying to build that out to get like to become more like ANSI SQL compliant, get like TP-CDS and all that stuff running smoothly. All right, so Catalyst. Does things like so basically. Your data frame hands Catalyst this DAG, right? And Catalyst can like rearrange things. It can kind of dig deep. It sees the whole execution and can do things. It like can eliminate subqueries. It can like collapse filters. The big thing here that we'll talk about quite a bit in a second here is predicate pushdowns, right? So basically the ability to as deep down into the source itself. And like you'll see this when we talk about the data sources API, there's ways to actually push filters down so that you aren't returning that data. Yes, I'll show examples of that where you can actually check to see. And I think I actually found a bug in the Spark-Cassandra connector this morning, so I have to like track down Russell and those guys after this. Because I can't seem to get it to push down. So it's probably something I'm doing, but it's not clear. So. There's hooks for custom rules. So you can implement your own rule if you want to override and, or, which would be totally silly. But they're basically Scala case classes if you implement rule. So OAS is org, like Apache Spark. That took me about 6 months at like Databricks to figure that out. All right, so at the top is there's this sort of concept of a DataFrame DSL, right? So it's all the familiar things, selects and filters, and if you run explain true on it, or from a SQL standpoint, just like put explain at the beginning of your SQL, it's going to be the exact same thing. It's going to dump out the parse logical, the analyze logical, the optimize logical, and then physical. So keep an eye on these. It's like logical without the word plan, analyze without the word plan. That bites me every time. So what you'll see here is the sort of early phases. So there's two filters at the top there, right? There's 3 types of genders in this data set. There's female, male, and then unknown, or undetermined or something. So here, I'm specifying it separately, so it shows up on like 2 separate lines. And then, this is kind of simple stuff, but yeah, this collapses it into, so if we stuck with the parse logical or the like analyze logical, that would like require 2 passes through the data. So of course we can collapse those filters and just do 1 pass. And then, yeah, you see that in the physical. And then, yeah, so up top is kind of a like generic, this is on the Spark like documentation site, the Spark SQL programming guide, but yeah, it kind of shows there's some cost analysis going on. So after physical plans are chosen, there's a cost step where basically there's one optimization that's there right now, and that's the like broadcast join, right? Like broadcast hash join, which it's basically map side join, right? It'll broadcast out the smaller table to the larger table so that you don't have to shuffle as much. Here's the data set. I think I was gonna, yeah, so here's the data set. When I started on this Spark After Dark thing about a year ago, this was the only dating, or like public dating data set that I could find. So like suits my needs. It just does simple joins, and I could do partitions based on the rating, partitions based on gender, things like that. So let me actually show that. Okay, hopefully Zeppelin has settled down here a little bit. So I just kind of threw this together this morning, performance comparison. Right, like with these notebooks, you can put in Markdown, you can actually run shell commands. Please don't hop on this server and there's no protection. Please don't delete everything. I mean, it's a Docker image, so you're not gonna get that far, but yeah, so we're basically gonna join ratings and genders, right? So ratings have user ID, have both user IDs, and then rating, and then I wanna get their gender. So like pretty simple, but the thing to note here is that CSVs, JSON, you cannot partition by those right now. Yeah, they're not supported. I think there's work going on specifically for like JSON, but still, actually, I think it might be experimental in 1.5, but now with Parquet, so yeah, Parquet is like the most popular format amongst Databricks, amongst everyone that I come across. So super tight compression, right? Like very, very, it's good for these analytic workloads because all the columns are stored together, similar to Orc. Which by the way, there is Orc support as of Spark 1.4, I think. So if you guys are still using that, that's supported now. So just kind of comparing, the whole point here is where are pushdowns happening and how effective are they? So CSV, just kind of pulling things in here. I want to point out one thing. If you see a filter in your physical plan, that's bad. So this means, this is CSV where there's no pushdowns, right? So this means I'm pulling in all the data and then Spark has to filter it. So my query here is, I'm trying to find, like the medium hotties, I call it. It'd be 4 through 6, if you're rated 4 through 6. This is, that way, I just wanted to have 2 filters there. So where and filter are just aliases, so they're the same thing. And then I'm printing out the logical plan, all the plans. So you see that the filter gets collapsed, so that's kind of nice, but it's still there on the physical plan, so that's not good. So now let's check out, oh, and then here's the join. Yeah, it's just not good. It's still there. So let's do, so now we have genders and ratings are both JSON. So now what's happening here? Let's do an explain. We still have the filter at the top. So that's not good. So let's fast forward here a little bit for the sake of time. Oh yeah, one thing, oh yeah, yes, I'll show you in a sec. So this is Parquet unpartitioned. So any kind of push downs, yeah, so Parquet is good at column skipping, right? Because it has all the columns together. If it knows that you only want, that you're only selecting one out of hundreds of columns, it'll physically skip over those, right, on disk. But it's not partitioned by rating, so let's look at the bottom here, filter. Yeah, that's not good. Now, if we do, let's get to the good stuff. So this is, so now both, so I've basically partitioned both data sets. I've got the one by the gender and then one by rating. So now let's see how things evolve here. So we have these two, they get collapsed. That's pretty cool. And then boom, right there. And so this changes too. This is union RDD. So this is taking the bare minimum and then sticking them together. If you see map partitions, that means it has to do a full scan, and that's not good. So let's get to Cassandra here. Oh, and if you have one that's partitioned and not the other, you'll see, yeah, let's see, where did I do it? Unpartitioned. Yeah, so one has the filter and one doesn't. So it's going to do it has map partitions, which is bad, and a filter, and it's got union RDD, which is good. Unfortunately, this is the smaller table that is benefiting from the actual partitioning. I did that on purpose. What is this? Oh, yeah, I tried to switch over to 1.5. So the best here, oh yeah, so basically what I found with Cassandra, I was trying the 1.5, like the new connector to see if it fixed the issue, but you'll see filter on top and then map partitions. All right, so I've got I think a minute here. This is new in Spark 1.5. You can actually see all these optimizations happening and the effectiveness of your filters. This is the data sources API. These are things, if you're going to write your own, you have to implement these. The one to keep an eye on is pruned filter scan. That's the one that's basically the holy grail. That's column pruning and predicate pushdown. So I'm working on DynamoDB just because, I don't know, I signed up for it a while ago and I'm still working on it. But if you want to create one, this is what you do. Just basically look at the existing ones. So far, the most complicated two that I've seen are the Cassandra and the Elasticsearch, right? And then Parquet, of course. But yeah, keep an eye out. If you guys don't know Spark packages, if you do contribute your own data source, right now IBM's obviously working on DB2 and their big SQL and some other integrations. As of about a year ago, maybe a year and a half ago, right, Databricks doesn't accept anything into the core that is vendor specific. So that kind of slowed my DynamoDB progress because I wasn't really going to contribute much except for my Dynamo friends. Partitions, pruning, pretty basic stuff. Pushdowns, this is showing how Catalyst is pushing that filter deep into the source. So yeah, I did this on purpose. It's kind of ridiculous. These are all the rules, but for Cassandra, right, obviously anything that's going to get pushed down has to be part of the partition key. And there's some weird like combinations of things and certain rules and stuff that still like applied to the partition key, and where the partition key is, the first or the last, whatever. So native, JDBC, JSON, so Parquet. There's this method partition by. So this is actually how I created the like partition data when I was testing it this morning. Was I loaded it in from JSON, I converted it to Parquet, and then chose a field, gender, or rating. So there's CSV. This is actually built by Databricks. This gets released every big release. They update it. Avro, same thing. Redshift, right? Like Databricks Cloud, the product is built on Amazon. So of course, right? Like a lot of our customers have Redshift. So Redshift's pretty interesting because the Redshift server, the like Redshift master, is a single bottleneck, right? So yes, anytime that you're returning super large number of results, that's obviously not going to be good. So what we do is we actually write out to S3, and then we can parallel pull from that. So within like Redshift, there's, I think it's called unload, and you give it that S3 and that like temporary bucket to store it in, and then we can parallelize from there and then pull the data in faster. There's an upcoming meetup. I think it's February. It's right before the Elasticsearch conference coming up, February 2016. So we'll be doing the same thing I did on Monday with Russell and the guys from DataStax. We'll be tearing that thing open. Let's see. Cassandra, of course. This is kind of a cool one. There's a REST data source that, so this is Michael Armbrust. If you guys have any questions about Spark SQL, he's not that hard to find. Right, like Databricks is a startup, so people like to choose their first names, obviously, when you're a startup, so fill in the blanks there. But he's super active on the Spark user list too, so posting there is the best thing to do, but it's kind of cool. Like you can give it a REST endpoint, you can write and read in a RESTful way. I'm working on Dynamo, me and Ehrlich. I think this is one of the last slides here. Performance tuning. I'm not going to go over these specifically. I'll post this on SlideShare right after, but some of the various things. Like you definitely want to turn on tungsten, bump this value up, shuffle partitions. People always forget about that one. It's a huge bottleneck. Turn on partition discovery. That's when you're reading. You could point to a parent directory. It'll infer all the partitions. So if you have it by date or gender or whatever, it'll figure that out. I'm heading to Spark Summit Amsterdam. Anyone going to that? Spark Summit? Please bail me out of jail. That's what the little police guy is. And then the 13th is my birthday in Scotland, so that's not going to be pretty. And so that's it.
All right, Chris, thank you very much.